It's so small, Tim.
I know. Good afternoon.
Mm-hmm. Oh, yeah, it's on. Oh no, can y'all hear it? Can y'all hear those of you in the peanut gallery, y'all can hear? Can you hear him? Yes? Okay. Tim, you're not hearing the thing, so...
The peanut gallery changed, didn't it?
Yeah.
Went away on spring break and the peanut gallery changed.
Mm-hmm. Yeah. Okay. Well,
the name of this section is Operations on Functions, Difference Quotient, and Compositions of Functions. Now, the operations are just the plain 4 basic operations on real numbers: addition, subtraction, multiplication, and division. We can just extend it to the idea of functions. And here's something that's nice. Addition, subtraction, multiplication, and division of functions is really just algebraic addition, subtraction, multiplication, and division. So for the operations, the first 4, there's not anything really new. It's just a matter of notation, using the function notation. But we know how to add algebraic expressions. We know how to subtract and multiply. We know we need like terms in order to combine. So anyway,
way back on March 1st, we began our discussion of functions.
Today was the 19th. It's the 20th.
It's the 20th. Oh, not the 21st. It's the 20th.
Okay, I need to change the date.
Okay, so back on March 1st, and what I recall was a really messed up class. Is that when the internet kept going down? Dr. Kenny Wallace was in here, and everything just messed up. But anyway, we said a function's a rule which assigns every x value exactly 1 y value. We talked about domain being the set of x values, y being the range. Before spring break, we discussed particular types of functions called piecewise and quadratic functions. That was the last lecture before spring break on March the 6th.
Seems like months ago.
Yes, it does seem like well over a month. But last spring break was much longer than it should have been. But, or it felt like it anyway.
Some weeks seem longer than other weeks.
So today we're going to be discussing first is a hodgepodge. There's going to be some operations on functions. By operations we mean add, subtract, multiply, divide. Then something called the difference quotient. And something called composition of functions. Total of 11 problems in the assignment. So new problems. So that means we did up one in assignment with only 1 or 2 problems. So that's why they're all 3 together. Let's start off with problem number 1. We don't need to tell them anything before we get going. Let me write it down. F of x is that a 5x plus 2?
Yes.
And g of x is what?
4x minus 7.
G of x is 4x minus 7. This is one of those 8-part problems.
G, f minus g, f times g, and f divided by g.
Yep. Defining f plus g, f minus g, adds the functions, subtract them, multiply, divide them, and then we have to give the domains. So the first thing is f plus g. Look at how it's written. F plus g is in parentheses, and then the x. F plus g of x. Well, that just means add and write down f of x and write down g of x. I'm going to put the purple plus right here. So f plus g of x just means f of x. So I've written down the blue function, f of x, This purple plus is the purple plus that's between the f and g that we're told to find. And now I'll write down g of x, 4x minus 7.
Y'all know how to add algebraic expressions. Y'all know what y'all are going to do here. If we came in here today and just wrote this down there and said, what do we have to do? I think y'all would have said combine like terms. Or you would have at least said add the x's and add the things that don't have x's.
Mm-hmm. So we're combining like terms.
I like to enclose that first set of 5x plus 2 in parentheses, but it's an unnecessary set.
I was going to state that in a moment. But you see, we could write it like that if it helps you see it better. This is the function f plus the function g.
Now, in a minute, we're going to have a minus. What do we have to do when we have a minus in front of a set of parentheses?
Starts with a d.
Distribute.
Yeah. Mm-hmm.
But a plus, that's like multiplying through by a positive 1. That doesn't change anything. So these parentheses here are unnecessary.
So we have what? 5x plus 4x?
5x plus 4x gives us
9x.
Now combine the constant terms. You have a positive 2 plus
minus 5. Did y'all hear that? Yep.
2 minus 7 gives me that minus 5.
So f plus g is 9x minus 7.
No, 9x minus
5. I'm looking right at it. Oh, wow.
We have to find f minus g, f times g, and f divided by g, but I'm going to be entering in the answers as we go along. Otherwise, I'll get timed out and signed out of my lab, okay? So, personally, I'd rather go through and get all the answers, then come over here and type it in, but
9x minus 5. Oh, could you go one more control shift? Would it make it? Okay, that makes it a little better.
Okay, now we want f minus g.
Okay.
But I've already told you all the punchline about this one. We know what we're going to have to do for f minus g.
Look at how they write it. F minus g of x. So we do exactly what we did up here. I'm going to write down f, then minus g. F is the blue function, 5x plus 2. G is the black one, 4x minus 7.
I like to remove the parentheses.
Mm-hmm.
Oh, okay.
So, with subtraction, you've got to distribute the minus. I think at the beginning of the semester when we were adding and subtracting complex numbers, that was the deal with complex numbers. If you're subtracting, you've got to remember to distribute that minus. So I'll put these little marks here to mean distribute the minus. So what do we have? A 5x plus 2.
That first set of parentheses is unnecessary. There's nothing in front to distribute. I guess you could think of it as being a positive 1, but multiplying by positive 1 doesn't change anything. Nothing in front of the parentheses, so we just drop them. But now we distribute the minus.
Did y'all hear that?
The 4x became a minus 4x. The minus 7 became a plus 7. And now it's just like the first part of the problem.
X plus 9? Yeah, that's right.
5x minus 4x is 1x. 2 plus 7? I agree. X plus 9. Is there any new algebra here? Anything that we haven't done before? No, it's just this notation. What does this f plus g and f minus g mean? Okay, but the algebra combining like terms, that's nothing new. What did we say? X plus 9?
Mm-hmm. No, before you. Okay. Okay. But look at how they're writing that.
Sorry, what is the fraction part about that?
We haven't gotten there. That's f divided by g. We're going to
and just that division is always the hardest. Trust me, that's going to be the hardest part of the problem. It isn't really. I'm joking. Okay.
Okay. You may decide that division is the easiest type, okay, the easiest part of the problem when we get to it, so don't panic. Now this thing here, just FG, I don't see a symbol between the F and G, so what do we assume that symbol is? Multiplication. F times G.
So this time there won't be a symbol. I'm going to write the F and G.
Have you already written? Yeah, okay.
But I'm not going to have a symbol in between them. I'm looking for a 4-letter word that starts with F.
Remember I said that it's just plain old addition is plain old addition of fractions is plain old algebraic addition. Oh, not addition of fractions, addition of functions is plain old algebraic addition. Multiplication of functions is just plain old algebraic multiplication. I bet y'all can tell me, how are we going to multiply 5x plus 2 by 4x minus 7?
40.
Okay, 4-letter word that begins with
F. So we're going to FOIL it out. We'd have a 20x squared first, outer minus 35x, inner,
And what's the last going to be?
and last, minus 14. Good.
So we have a couple of like terms we can combine. Negative 35x plus 8x.
What am I thinking?
Negative 35 plus 8.
So 35 minus 8, is that a, I'm thinking 27.
I'm
Okay,
thinking
so-
of minus 27x.
So we have 20x squared minus 27x minus 14. Oh, no.
Lift
If
it
you
up,
wanted-
Tony, lift it up.
Oh. Oh, wow. I never would have even thought of, now try to factor it, but actually,
It's
that
already factored.
oh, wait. Oh, my gosh, you're
5x
right.
plus
Here it
2
is. It's already
minus
factored.
7.
If you
It's
factored
already-
it, you'd get back to what you started with. Okay. Okay, so 20x squared.
Have y'all typed exponents yet? It's amazing what I've forgotten. Have y'all typed an exponent? Yeah, I think so, with circles maybe or not. Use the little, I don't know why that thing doesn't say exponent. It says superscript, just like this thing's a subscript. Y'all see which hot button I'm using? There's a little blue dot there, a gray box, and the blue dot, you
I
click
think
it,
most people are
there's the
savvy
square.
enough to figure out that's where the...
and then get out of the exponent by tabbing or using a right arrow, minus 27x minus 14.
Okay. So now we've done the F plus G, the F minus G, the F times G. Now,
The F divided by G.
look at how they have it written. Notice, they could have written F of X plus G of X, but an F of X minus G of X, but they're writing the X just one time. Okay. This just means F of X over G of X.
Okay, let me switch over to the camera. There.
Oh, I should have made that line. Well, okay.
There's the division bar, the fraction bar. F is on top.
What am I going to write in the bottom here, the fraction? Yeah.
Right. Now, if I saw something with exponents, I would go through, okay, can I factor it? Maybe I could factor and cancel. But when you look at this, a binomial over a binomial, is there anything you can factor and cancel?
If you think there's something you can cancel, you're mistaken. Okay? Don't think, oh, I'll cancel those X's. No, you can't do that. This is it. That was the joke of when I said division was going to be so hard. You're just writing F over G.
There's nothing
Okay.
you can do to cancel. I mean, you can't factor or cancel. Normally, when I run into an algebraic fraction like that, I ask myself, can I factor something and cancel? Nothing can be factored. There it is.
Are you going to type it in now?
I sure am. So I'm going to come
Wow.
over here. What do y'all think I'm going to click first? To type in that fraction. I'm going to use the fraction bar, that's right. And then on top I have a 5x minus 2.
Plus 2.
Plus 2. And on bottom I have a 4x minus 7.
And we are now halfway through with this problem.
Because notice what else it says to do. Give the domain of each. So we're going to have to give the domain of f plus g, f minus g, f times g, and f divided by g.
Now, looking back, I was going to mention this before we started all of this, that when I was mentioning, we've defined functions on March 1st. Also on March 1st, we discussed how to find the domain if
Suppose there's no square root and no fractions appearing in your function. Unless you're told otherwise, what do you assume the domain is going to be? What numbers can you plug in there for x?
Yep.
Okay, or any real number, from negative infinity to positive infinity. Y'all remember us saying that? Remember, you don't want a denominator of 0. In number 16, you have a denominator of 0 occurring, because they're fractions. But there's no fraction in the function, so we don't have to worry about denominator of 0. There's no square root appearing, so you can't get the square root of a negative. No fractions, no square roots, and you assume the domain is all real numbers.
So, looking at these, look here, is there any number you couldn't plug into 9x minus 5 and x plus 9? Like if you were going to plug a huge number into 20x squared minus 27x minus 14, you might want a calculator if you're going to plug in 133.8 or something. But there's the domain. That's what the domain is. What numbers can you plug in? So I'm going to make a note.
What I do is I look through the problem also.
Yes.
And just verify that nowhere along the work did you pick up a square root or a fraction bar. Because if you pick up a square root out here, you could run into the possibility of imaginary numbers. But do you see any square roots or fractions on any of the work for f plus g, f minus g, or f times g? See any square roots or fractions in that the problem work for those first 3 problems? Say no, you don't see any. In which case, the domain is all real numbers for the first 3. And we're going to have to type that in separately. F plus g, f minus g, f times g. Any questions over there? What about you in the peanut gallery? Any questions on why we're saying the domain for the first 3 is all real numbers? No square root, no fractions, domain is all real numbers.
So, but the third one does have a square root, so why?
Where does it?
No, a square, not a square root. A square root is that little symbol, not an x square. X square is fine, but not that little square.
As a matter of fact,
wait,
right
can it not
here,
see it?
right there, you see we had a square in this one. We're finding the domain, and the domain was still all real numbers. It's the square roots you have to be careful of. Yes.
What about the division?
We're not there yet. We're not there yet.
Good question.
Okay, let me go back. For f plus g, f minus g, and f times g.
Years ago, I remember I was at a Pearson workshop, and they asked, is there any suggestions for improving my math lab? And I told them, you should have a hot button that's nothing more than negative, parentheses, negative, infinity, comma, infinity, close parentheses, so you don't have to type it in over and over again. And the lady just looked at me, didn't say anything. And then she went on, any questions? And I thought, they're thinking that idiot,
Lazy
that
idiot.
lazy
He doesn't
idiot.
want to have to type in
negative infinity, comma, infinity. But I guess you're looking at what he did. He
copied it and
pasted it
Control
in.
C and then Control V to paste it in. If you're one of those people that gets tired of typing the same thing over and over. Now we're ready for f divided by g. Let's go back and remember what we said. Look back at I think number 14 was it?
Number 14? Oh, yeah, look at number 14.
Scroll up. This is from that section over finding domains. It's a fraction. Remember, there are two things we want to avoid when finding domains. The square root of a negative and a denominator of 0. Here, we have a denominator. We can't let that denominator be 0. Do y'all remember doing that? Yes. And then to say all real numbers except that, you have to use parentheses, negative infinity to that number, union, number to positive infinity. That's their way of saying all real numbers except 8. I personally would prefer writing it out in words. All real numbers except 8.
Because anyone that can read English can read those words. They may not understand what a real number is, but at least, like, someone looking at this, what the heck? You know,
unless you know how to read interval notation, you wouldn't know what that does.
Yeah, my 95-year-old mother can read all real numbers except 8. But this thing here, if I told her, I don't even know what she would do. How would she? I think she'd just
ignore it.
Yeah. Okay, so we got to now find the domain.
Oh, wait. I wasn't.
Okay.
I was about to go type in negative infinity to 8. That's not the.
What is the domain of f over g? I'll just write the 5x plus 2 over 4x minus 7.
So it's a fraction. We don't want the denominator to be 0. Okay. Okay.
Okay, so I'm going to say cannot be 0. If you want to say equals, okay. Move the 7 over by adding 7. And then what? Divide by 4. So, yes. Did y'all hear that? X can't be 7/4. In real numbers, in words, we'd say all real numbers except 7/4. But we don't type it out in words. So we think of it as a number line. Can y'all see how the interval notation would look like without drawing out the number line? It would mean open circle, exclude the 7/4. Everything else would be negative infinity to 7/4, union 7/4 to infinity, all parentheses. Am I writing too low, Tim?
I don't know. Don't ask me. It looks great, but I'm just looking here at the monitor. Can y'all see it down there? Yes, okay.
See, I really think that
spring break was too long.
And that math education did us all a disservice by doing away with words and using the symbols for everything. Okay.
Okay, so here, oh no. So left parentheses, negative infinity, comma, 7/4.
Make sure you don't put the parentheses down there with the 4.
Union, left parentheses, 7/4. Get out of the denominator before you put your comma.
Yeah, try not to don't put that comma down in the denominator of your fraction because it might count it wrong then.
Mm-hmm. And if it's a homework problem and you do it, okay, it's counted wrong, you can correct it. But on a test, if it's counted wrong, it's just counted wrong, okay?
If someone saw that
and pointed it out to me, I would give them credit for it, but still. Okay.
Oh, wow. So we're 24 minutes into this and we've done the first problem. But should we be panicking? Was it excessively hard? Or were we too loud? Or too long-winded,
Long-winded. We were long-winded, you're right.
But So that was the operations part of the assignment. Okay? The add, subtract, multiply, divide.
We're not going to do much with that just because it's not anything new in terms of algebra. Now,
next thing, we're going to have two problems dealing with something called difference quotient. And, okay. Okay. I want to review something that we had said about when we're working with function notation. If you had numbers in the parentheses, you plug them in for x. So I remember doing that stuff. Like here on this one, we had to actually find k of c plus 5. And we said whatever's inside the parentheses, you plug in for x. Okay? It's just stuff we were doing. Like f of m, well, replace the x with m. Oh, here was a messy one, number 11. Find f of 3n minus 4. And I'm just reviewing or trying to jog your memory on something that we did back on March 1st, 19 days ago, in a really terrible class period. If I'm remembering this correctly, this was the day we didn't really even get a video. We just gave up on that. And I think my brother took an old class's video and put it on this playlist, okay? But whatever's in the parentheses, you plug it in for x. So, if we look at problem number 2, it's a 3-part problem. Let me write it down. It says, for the function f of x equals x squared plus 7, part A says to find f of, and what's in those parentheses? Is that a x plus h? This is a 3-part problem. So f of x is x squared plus 7. First thing we're told to do is find x plus h. F of x plus h, sorry. Well, whatever's in the parentheses, you plug in for x. So that means that this black x here, I'm going to replace with an x plus h. In place of that black x, I'm putting an x plus h. And notice how I put it in parentheses? How do I square a binomial? What am I going to have to do to square the x plus h? I'll give you a hint. You don't just square the x and square the h. It's a 4-letter word. Foil it out. That x plus h squared, I'm just going to come right over here. This is going to be my scratch paper. I'm going to foil out x plus h times x plus h. If I'm foiling out x plus h times x plus h. For some reason my paper's curling up. It would be x squared plus xh or hx, it doesn't matter. That's first outer. What about inner? hx. I'm gonna, since I wrote it as xh here, I'm gonna write it as xh there also, just so I'll be sure to notice that those are like terms. And what about the last one? H squared. So I've already mentioned like terms, xh plus xh. I'm gonna so it's x squared plus 2xh plus h squared. There. And Why did I do that? I'm just foiling out the x plus h times x plus h. So having done that, I'm almost through with the first part of this problem. The x plus h squared I'm going to write as x squared plus 2xh plus h squared, but I still have this plus 7. There's your answer for f of x plus h. Are there any questions there?
So you just tack on the second.
I just tacked on. Well, I do have the x's in descending order, x squared and then x. If you want to put the x's in x squared plus hx squared, then the plus 2xh plus 7, that's fine. This is one of the things that doesn't matter at all how you write it, the order. Okay? Because since there's two variables, you really can't get it, you know, at least the x's are descending. The h's are ascending, aren't they? But the x's are descending. So I'll come over here and I type in x squared, right arrow, plus 2xh plus h squared, right arrow, down arrow, whatever to get out of that, and then plus 7. And that's called f of x plus h. Now, let's do the second part. Part B says to find f of x plus h and then minus f of x. F of x plus h minus f of x. Well, for this part, you can make it as many steps as you want. Okay? So I'm going to write out some stuff just to fill up some space. But really, all you got to do is look at your answer to part A and this, and there's not really any work to it. Take your answer from part A, and then think of this minus as take away. Isn't that how you first saw subtraction back in elementary school? Oh, shoot. Huh? Oh, thanks. There. So for f of x plus h minus f of x. This is the second part of the problem. Take your answer from part A and take away everything that was in the original function, f of x. So look at this answer. Take away the x squared and take away the plus 7. Here's what I'll do. I feel like there's the answer to part A. Take away the x squared and take away the plus 7. Sometimes students say, well, wait a minute, what if there's not an x squared here to take away? Then you messed up. You're doing something wrong. And so what am I going to type in as my answer? 2xh plus h squared. That's the f of x plus h, take away f of x. Part A is the difficult part of the problem. Now, for the second part, you're taking your answer from part A, take away stuff from the original function. In the original function, there was an x squared, so I marked it out. There was a plus 7, so I marked it out. Leaving just the 2xh plus h squared. Any questions how I got the 2xh plus h squared? So you're looking at your answer from part A. Just take away the x squared and the plus 7. Take away the x squared and the plus 7. So even though I wrote out a lot, well, not a lot, you could do that one without much writing as long as you did part A correctly. Plus h squared. And then, if you hate fractions, then this has to be the hardest part, right? Part C. F of x plus h minus f of x. Have we already done that? The top part of this fraction, have we already done that?
Yes.
That's the part B answer, all over h. Any future engineers out there, once you get into calculus, you'll see this funny looking fraction a lot. Also economists, any future economists will find, well, by the time you get into your economics class discussing margins, you would have long forgotten probably that we did this in algebra class. But for f of x plus h minus f of x all over h. Take your answer from part B and just put everything over h. Let me show you what I mean. Here's my answer from part B, 2xh plus h squared. Put each one of those terms over h, and can I cancel those h's right here? See what I'm doing? Canceling the h. What about right here? If I cancel the h on the bottom, it's just going to be an h. So after all, can y'all follow what I did with all this marking out here? What's left? 2x plus h. It's not really a difficult thing or a difficult process. Part A, the first part, that's the messy part. And you'll see it especially in the next problem. The next problem is a little bit messier than this one. 2x plus h. 2x plus h. So what we have here is a three-step process for finding something that's called the difference quotient. This messy fraction is important enough that it has a special name. It's important enough in future math classes and higher level business economic classes. We're not going to do that much with it. We're about finished with it. Well, we have one more of these. But it's called the difference quotient. Difference means subtraction because there's subtraction up on top. Quotient means division. We have a three-step process for finding it. How will we do this one here? Notice, it just says this expression, and it says h can't be 0 because what's the one number you can never have in the bottom of a fraction? 0. So this expression is called the difference quotient. Find and simplify the difference quotient for this function. F of x equals 7x squared plus 9x plus 4. So instead of walking you through the three steps, it just says give the final answer. we're still going to go through the 3 steps like we did on problem number 2. We'll find f of x plus h. That'll be the lengthy part of the problem, because the rest of it falls out real easy. Just mark out everything in the original function and then put that over h. So, to do this problem, I would start off, I did a lot more writing here than I really needed to. What I would have done is just found the first answer, okay? If I was sitting in my office or if a student were asking me to work this problem out, I would show them how to get the first answer. X squared plus 2xh plus h squared plus 7. Then to do the rest of the problem, to do the minus f of x, I would just do that and that. And then what would I do to do the over h? Just go over h over h. You see, it's not really that long. I just sort of wrote out more than I needed for these second and third steps. And I cancel that h with that. And we'd have 2x plus h. Okay? But it's finding that f of x plus h that can be a little lengthy. So let's go to problem 3 and write it down. Don't panic too much if you're the panicking type. F of x equals 7x squared plus 9x plus 4. And it doesn't actually say find f of x plus h minus f of x all over h. It says find the difference quotient. But that's what you're looking for. Now I'm going to color code all of this. I'm going to start off, okay, I'm going to use blue ink to find the f of x plus h. Then for the take away f of x, I'll use red. And, let me see, does this green look good here? Does that green show? Brother's always criticizing the green. There. And then for the over h, I'll do that in green. But the lengthy part of the problem is that first part, the f of x plus h. So I'm going to do that in blue. To do f of x plus h, you plug an x plus h in place of the x. So in place of the black x, I'm going to put a blue x plus h. See what I've done? To get started, I'm doing the f of x plus h. To find the f of x plus h, you replace these black x's with the x plus h. Now, how do I square the x plus h? What am I going to have to do here to square it? Yeah, FOIL it out, which is why right here I said, here's my scratch work. I'm going to FOIL it out right here. The x plus h times x plus h. So in place of the x plus h squared, I'm going to write x squared plus 2xh plus h squared. Okay, I'm taking it from there.
Oh, I see.
Okay, that's what I was trying to show. And now, oops, right, that is what I'm writing right here. And of course I made my parentheses too small, or else I wrote too large. Okay. You'll see where I got the x squared plus 2xh plus h squared. That was where I'd FOILed out x plus h times x plus h up here. I'm going to put a star out beside it, because you'll need that for problems 2 and 3 in the homework. Be able to FOIL it out. If you want to just FOIL it out twice, okay. Now, I would just distribute the 9. Notice the x plus h isn't being squared here. It's just 9x. Is it clear why I'm not squaring that? And we still have the plus 4 here. I'll just carry down. Still one more thing I need to do here. Distribute the 7. And when I do that, I'm practically finished with the problem. Okay? We'd have a 7x squared plus, is that a 14xh? Plus 7. Oh, you said h, I wrote x. I'm sorry. H squared. We still have the plus 9x plus 9h plus 4. The reason it's not broken up into 3 parts is it would take you a lot longer, because you'd have to type all of this in. So it's actually a good thing it isn't broken up into part A, part B, part C. Any questions on the 7x squared plus 14xh plus 7h squared plus 9x plus 9h plus 4? It's all downhill from here. How do I do the minus f of x? Well, go to your f of x plus h, take away the 7x squared, there, and mark it out. Take away the 9x, and you might think, well, wait a minute, what if I don't have a 9x? What if I have a 7x? You messed up. There better be a 9x I can mark out, is there? Yeah, right here. And what's the other thing I'm going to mark out? 4. Okay. So that was the taking away of the f of x. Any questions there? Everything in the original function, the function that you were given, you're marking out now. And there's one thing left to do. Over h. So I'm going to go through, go over h, over h, over h. I'll give you a hint. Those green h's, the h in the bottom, better cancel every time. If it doesn't, you're messing up. Is it? Yeah, right here I cancel. Now this green h, I cancel with one of these blue h's right here. So I'm just going to mark out the exponent, which is what I did up here, and didn't even mention it as I did it. What I was doing was marking out the exponent there. And right here, just the h's cancel. So what's remaining? 14x. Ooh, let me lift it up. 14x plus 7h plus 9. There it is. You want to type it in, Tim? See, am I wrong when I say it's the f of x plus h part that's the lengthy part of the problem? The take away f of x and the divide by h, that falls out real quickly. 14x plus 7h. Yeah. See if it's right. Oh, okay. Any questions on that? Even when they don't tell me to break the problem into 3 parts, if I'm finding a difference quotient, even if I'm in, say, a business calculus class,
I break the stuff into those three parts that were used in problem number 2.
I wonder, if you click view an example, I bet you on number 3, how do they go about it? They try to get it, they don't break it into 3 parts, or do they? Oh,
Well, they find f of x plus h. Maybe
oh they
do.
are. Okay, good.
Oh.
And then, well, they don't do the takeaway, they're distributing a minus. Oh, wait, no.
Oh,
wow, I don't like that. Okay, well, we don't have to use the view an example. Now, so we've done, wow.
We're just going and going, aren't they?
Okay, well, now for problems 4 through 11,
Wait.
it's something.
There's something new, but let's go back.
Oh.
Now, did you mention, Tony, that in the takeaway part, the f of x plus h minus f of h, minus f of x, that takeaway part, the only thing that's remaining should have to contain what letter, or has to contain what letter?
That's a good observation.
H, okay. And that takeaway part, the B part, the only thing that's left are the terms that have an H. Anything that doesn't have an H, notice they're being taken away. Okay?
Because I did mention that the H's here must cancel.
Yes.
Okay, if you have something and the H's don't cancel,
You have to have an H in
messed up
every
somewhere.
term that's left over there, so that when you put it over H, the H is canceled. That leaves one, the H in the denominator cancels.
So now we're going to start the third part of the assignment,
Composition of
functions.
That is the new operation. We already have addition, subtraction, multiplication, and division. And those they used to apply the good symbols with addition, subtraction, multiplication, and division, quite frankly. The little T for addition, a dash for subtraction, nothing or a little X or something for multiplication, and little dash with a dot above and below, and or a fraction bar for division. And so they had to come up with a new symbol to represent composition, and there it is. They used a little O.
Little open
F composed
circle.
with G.
It looks like I've written fog there, okay? I'm defining what that little circle means. That little circle is just being used in place of a big set of parentheses. F composed with G of X means F of G of X.
You're plugging G of X into F everywhere there's a variable. Composition of functions is really just repeated function notation.
Let's see.
But notice the order in which we're writing them is significant. If we had G composed with F, what would be on the outside there?
G.
The G and the F of X would be on the inside. Okay? But it sounds worse than it is. You just need to see an example.
Number 4.
We're going for almost an hour, and we're ready for number 4.
Okay. So instead of F and G, it looks like they're using F and H here. We have function f of x equals 3x minus 1. I know, but it really isn't that hard. Is everything we've done that difficult today, or is it just that we're being long-winded today? So f of x is 3x minus 1. H of x is
the negative of x plus 5.
Negative x plus
Oh, wait.
5.
Okay, now I'm going to switch over to the paper.
But we're told to
what is
find half 3.
H composed with f of 3.
Yes.
Yeah. Notice how Tony's right. 3.
Ooh, 3. 3.
I was going to say,
Okay.
Mark that all right.
There. There's supposed to be a 3 in the parentheses. Okay. You start with the number 3. Take the 3, plug it into the function beside it. So take the 3, plug it into f.
You're finding f of 3. That's the first thing you're doing.
Okay. Take the 3, plug it into f. Take that answer, plug it into h. Well, let's do the f of 3 first. Come up here and in place of the x,
F. Oh, yeah, you're right. Yeah.
I'll put a 3. So we have 3 times 3, which would be 9, minus 1. So I'm taking the 3, plugging it into f. So we have 3 times 3, 9 minus 1, that's 8. Take the 8, plug it into h. So take the 3, plug it into f.
But F is,
This one right here.
yeah, so where's that in the problem? Where's
3 times 3 is 9, minus 1.
So you just eliminate the X.
You replaced the x with 3.
And I didn't show 3 times 3, I just wrote 9. Maybe I should have written 3 times 3. So it's plugging this 3 in here. 9 minus 1. That's where we're getting an h. I mean an 8.
No, I got it. I just had to write it out.
Okay? Now take that 8, plug it into the function beside it, h. So in words, if someone asks you, what are you doing? Say it out in words. You're taking the number, plug it into f. That gave us an 8. Take that answer, plug it into h. So if I put that black 8 in here for h, in place of this x, we'd have a blue negative. And in place of that blue x, I'm putting 8 plus 5.
What's that going to give us?
Negative.
-3. You
So-
plug the 3 into f, that gave you 8. You plug the 8 into whatever function's here beside it, h, and that gave us a -3. It is repeated function notation. You plug the number into the function beside it, then you plug that result into the other function that's beside it.
And that's the final answer.
Now, if you wanted to, you could write it out formally, like this. H, big parentheses, f of 3. Okay?
And that's how I do it. And I will say that my students, when we were teaching these separately, my students seem to mess up on the composition, whereas Tony's got it right. That's why
you're
I'm
being
letting
too
him.
kind.
Yeah, but
But my method doesn't really get better until we start doing fog x and golf x. Then my
f of
better.
x.
Mhm.
Then I write a 9 minus 1. Have the h there beside it, but seems like Tony's method showing fewer algebraic steps here, showing less of the algebraic notation. Students seem to grasp that better.
But they've got to know, take this number, plug it into this one. Okay, that's what we're doing here. 3 times 3, 9 minus 1, 8. Take that answer, plug it into h. -8 plus 5, that's -3. Oh,
Okay, I better type it in before we get timed out.
oh, I forgot about that.
So what was it?
-3. Okay. What about problem 5? Okay, well, we have some tables here.
I remember we had functions. We were able to describe them as ordered pairs. We were able to describe them as graphs, and we could describe them using equations. Here, these are really ordered pairs. But the function f, 5 is assigned to 8, 7 is assigned to 5, and 10 is assigned to 2. Do y'all see how those tables, what they're doing? They're just listing ordered pairs. Table G. When x is 9, the y value is 7. When x is 4, the y value is 5, and so forth.
10, 20, and 21.
And it's going to take longer copying the tables than it is to answer this question once you understand what they're asking for. F composed with a G of 4.
In other words, fog F, the fog 4.
Tony
It's
says
not really fog.
he says that fog and golf just to annoy me, and so oh goodness.
Yeah.
One day I'm going to decide that doesn't bother me. But
Yeah.
I
Well, I
haven't
remember
gotten to
once
that
I
point.
told my students, you know, if you're in Calculus 1 looking at the chain rule and you say fog, and your teacher says, who did you have for algebra? My first name is Timothy Precella, okay? You really don't say fog. I mean, but
Well,
you
I
know,
know.
in a moment, you're going to have quite a few assignment problems that say find fog x, find golf x. At the end of the semester, you'll remember fog and golf. I don't think you'll remember the name composition of functions. Okay? So, okay, there's really not a lot of work to it. It's up here work. Start with the 4. Oh. There's nothing to plug into. There's tables to look at.
Okay, which table are we going to use first? The F table or the G table? The G, okay.
So G of 4 is what?
The G table assigns the number 4 to...
And then you do the
Okay, so 4 is assigned to 5. There's that new... G of 4 is 5. We still have to deal with this letter here, F. So bring down that F. F of 5 is...
There's 2 times that the number 5 is here in the F table. It has an 8 and a 7. Which one of those is the correct answer? F
5 is
of
assigned
5 is...
The F table assigns 5 to
8.
8. Okay. Once you find that 5, that becomes the new x value. 4, the G function assigns 4 to 5. The F function assigns 5 to 8.
And type it in. Okay. And I'm going to go ahead and make up another one of these problems because it's sort of unfortunate that there's only 1 4 in the whole problem. Y'all see that? But to get started, well, you look until you find a 4 up there, and there's only 1 4. So let's have it. That was right. Here's another number 5. I'm going to make up new tables. I'll put my F table in red. Oh, okay. 3, 7, 4.
Yes. It's the same type of problem.
But I want the same numbers appearing a lot. Just to make sure you're getting the pattern. 7, 9, 5, 3, 7, 2, 8. Okay, so there's my 2 tables. The first thing we're going to do is find fog. 9. Find F of G of 9.
Let's make sure they tell that problem's over.
Okay. I'm just going to label this EX. It's just some random example, not really random by any means. Okay. Do you see there's a lot of 9, or at least there's 9. Here's a 9, there's a 9, there's a 9. Which one?
First of all, which table are you going to use first? The G, okay. G of 9
G of 9 is 7.
I guess that's bad that you
I
have.
know.
She could have gone here. Make that a negative 7. Now make this one, the first one, a negative 7. So
Oh, this one here? Okay. There. So, G of 9 is 7.
and now what table do we use?
Mm-hmm.
Okay, so you go to the F table.
And F of 7 is
assigned
4.
to 4. You don't go like that. 7 is assigned to 4.
Now, what about if we reversed it? What if we wanted to find G of F of 9? Is it going to be the same answer? Let's see. First find F of 9. F of 9 is 2. Now G of 2 is 8. You see how I'm getting these numbers?
Okay.
Do y'all have the pattern? Should we do one more of those? How about one more? Fog negative 5. Fog negative 5. F of G of negative 5.
Okay, which one are we going to use first? Which table? F or G?
So G of negative 5 is 3. F of 3 is 7. I heard 7 right off, and that's right. Okay?
Any questions there? They don't like it when you're doing problems. You're just making up.
Well,
They want
okay.
to go on.
And get it. Oh, okay. Well, here's one. Let's not bother writing it up. It'll take so long.
I'm going to blow it up a little more. Okay. They give us a table F and G. They ask us to find F composed with F of 8.
Are we going to even look at the G table?
We don't even look at G.
That's just put there to confuse you. You're going to use the F table twice.
So 8 is assigned to what number? Using the F table, 8 is assigned to, I could hear you, 12, I agree. And then using the F table again, 12 is assigned to 9. I agree.
Any questions there on that one? Should I write it out? I'm wanting to get to, okay, so problem number 7. It says, let me write this one out. It says find F of G of X and G of F of X, or fog X and golf X. And here's, let me write out F of X first. F of X is 6x minus 8. And G of X
3 minus 4x.
is 3 minus 4x. And the first thing we're told to do is find F of G of X. I don't know why these pages are...
I refer to the outer and inner functions. The outer function is the letter that's written first. So F is the outer function, and G is the inner function. So if we talk about outer and inner functions, it's just the one that's on the outside of the parentheses and the one that's written there, the second one.
To get started. Now, wait, I guess, how does this differ from the ones we've done before? Well, on 4, 5, 6, there is a number here. So I'm showing you how to do if there's not a number in the parentheses, if there's just an X.
A composition at a number gives the final answer. That's a number. A composition at a variable gives a final answer. That's a function of that variable. So don't be surprised. There should be an X in your final answer. Unless you're just dealing with constant functions.
So, to get started, you're going to take g of x, plug it into f of x. Watch those arrows that I did. Plug g of x into f of x.
If there were more than one x here, you'd plug it in each time.
So, in place of that black x, I'm going to put the 3 minus 4x. Take this second function here, plug it into f. Take 3 minus 4x, plug it into 6x minus 8. In place of this black x, I'm putting 3 minus 4x. Now, how does this simplify? Let's see. We'd have 18 minus 24x,
and we still have
this minus 8. So, I think I'll just subtract the 18 minus 8 and call it a 10. If you want to write it in descending order, negative 24x plus 10, that's probably a better way to write it. I'll leave it as 10 minus 24x. If your brain starts thinking, well, wait, why didn't he write that as negative 14? No, I can't subtract the 10 and 24. Those aren't like terms. So I took the g of x, plugged it into f. I'm going to rewrite the problem. Oh, do you want to go ahead and plug in that answer so that we don't get timed out? Or type 10 minus 24x. Okay. The next thing we're doing is g of f of x.
We're reversing the function.
Oh, you know what? Okay, I'll just read it on this one. It's going to get a little messy now. On this one, we're going to take f and plug it into g. Plug f into g. So take this stuff, plug it into the function f. So in place of that blue x, what am I going to put there? The black 6x minus 8. I'm plugging f of x into g. 3 minus 4, in place of that blue x, I'll write 6x minus 8. And now how do I simplify that? Well, don't subtract the 3 and 4 first. What am I going to do? Distribute.
You don't keep the x on it?
Oh.
Versus 3 minus 4?
I'll replace the blue x with this stuff here. That's where the black x or the blue x is gone. I've got 3 minus, in place of this x, I'm putting function f. So in place of that blue x, I'm writing 6x minus 8. This x right here is the 6x minus 8. Now distribute the 4. So we have 3 minus 24x and a plus 32. Negative 24x plus 35. Is that what I heard?
My math lab will take 35 minus 24x also. As long as you have the negative in front of the 24 and the 35 is positive, my lab will take it. Now I'm going to type it out the way you said. Negative 24x plus 35.
It takes a little bit of getting used to. Let me see. If it's number 8, is that? I think number 8 might be a better example to show the pattern on these. Are there Any questions here on number 7 before we go on?
Any questions on number?
You'll see what we're doing. You plug G into F. Plug F into G. Number 8, we have f of x equals 5x plus 3, and g of x is just that square root of x. If we're finding f of g of x, or f composed with g of x, and you'll say what we're plugging in. We're plugging blank into blank. We're plugging f of g. Which one are we plugging? We're plugging
Blank of x into blank of x. Which one?
You plug in G into F.
Square root x.
You're plugging G into F.
So it would just be square root times 5x plus 2.
No.
I
You're going
think
to replace
you're
this.
replacing that black x.
Replace that black x with the square root of x, this purple.
Got the 5 and the plus 3,
Uh-huh.
but you're replacing this black x with
That. Replace the black x with the purple square root of x.
Is there anything we can do there to simplify or reduce that?
I don't know.
Oh,
It's just like
No.
oh.
Just a 5 square root of x plus 3.
Well, you'll get the hang of it because it's really not difficult. You're plugging this into x. In place of this black x here, you're putting the square root of x.
Circle.
Oh.
So I'm going to go type it in. So that's 5. Remember the square root of x. What do I need to do before I type the plus 3? Move over, get out from underneath that radical. The only thing that's under that square root is the x. Now we're going the opposite direction. G composed with f of x. That's
Because
switch.
I'm going to be doing these arrows, I rewrote f of x equals and g of x equals. I probably should have done that up here on number 7. But if we're looking at g of f of x, you're plugging f of x into g. So could y'all draw the arrows? What's going to get replaced over here? Uh-huh. In place of that purple x,
You still have the purple square root
Uh-huh.
symbol. You still have the purple square root symbol, but the x is replaced with the black 5x plus 3, correct?
there's not a lot of work to this for me. It's not a lot of scribble work. If it looks to you like I'm just writing the problem down and writing the answer, yeah, that's what I'm doing. Okay?
But there's some thought.
And that's the answer. Let me circle it. See.
Any questions on that one? We've replaced the variable in G with f of x. In place of that purple x, we wrote f of x, 5x plus 3. There's the purple square root. We just scribbled out that x and wrote in a 5x plus 3. Let's... Okay, what am I going to click first? The square root is first because everything is underneath there. 5x plus 3. Any questions there?
You know, Tim, I'm looking for that pizza and pineapple thing that works so well explaining the difference between f of g and g of f, and I can't find it now. Do you have it on your phone? Well, anyway, I'll look for it maybe the next time.
Okay, number 9.
F of x is the square root of 5x, and g of x is a 1 over x.
I'm trying to find that because that is a good illustration.
Okay. You're going to plug g of x into f. So in words, what am I going to do? I'm going to come over here to this black square root of 5x, and I'm going to replace this black x with what? 1 over x. I have this black square root. I'm writing it down. Oops. I'm writing the black 5 down. In place of this black x, I'm going to put the 1 over x. Did you get it?
Yeah, I'm getting it.
Oh, okay. Well, we can go back and redo number 8 if you want, because I think 8 does a good job of showing how you're going about this. Now, to multiply this 5 times 1 over x, just get 5 over x. You would think of the 5 as 5 over 1 times 1 over x. I would just write it as a 5 over x.
Do you think they would take it with the 5 over 1 over x?
No,
Okay.
I don't think. Oh, okay. You're thinking of it as 5 over 1 times 1 over x, multiply straight across to get 5 over x. Any questions there? Anything? Y'all see what I'm doing? If you're looking and you're thinking, it looks like he's just writing the problem down and writing the answer, that's sort of what I'm doing.
It just didn't make sense at first.
Oh.
But it's just plugging it in.
Go ahead and do the other direction, and then I'll type it in.
Oh, okay, as long as we don't get timed out.
I think that it's going fast enough.
Okay. What about the rest of y'all? Y'all see how we're getting this? So we want to find g of f of x. Ooh, am I too... Let me see, do I need to lift my paper? G of f of x. This means I need to plug f into g. So let me draw the arrow. I'm plugging this into g.
Okay, so we have a blue 1 over, and in place of that x, we have the black square root of 5x. Well said. I know that back at the beginning of the semester, I remember saying, oh, don't leave a square root in a denominator and be rationalized. But it turns out there's not really anything wrong with the square root being in the denominator. I think we said, oh, don't leave a fraction under a square root. Then it's really fine. Okay.
So 1 over...
Well, first of all, f composed with g, that's the square root, where we had 5 over x.
Oh, yeah, we had it done the first thing.
Did it?
Okay.
What did I just do?
Say less.
Okay. And g composed
Now
with...
say less.
Yes. What did I do?
No, you hit more accidentally.
There should never be a time you have to hit more for the hot button, okay?
So,
And I don't know what the answer was.
1 over the square root of 5x.
So I'm going to use the fraction hot button. On top I have a 1. I click down in the bottom and I have a square root of 5x. Any questions there?
Y'all sort of getting what we're doing? I mean, if you look at the work, well, I'm drawing some arrows, but there's not a lot of scribble work here. Okay? All the work is going on up here. My friend, that used to be a butcher. Now he's an edible artist. No, it says there's 2 types of work when you're a butcher. The physical work, where you're cutting the meat and unloading the truck. And then the work up here, where you're pricing the meat and doing the math stuff. And he used to say that the physical work was easier. Well, he's older now. I bet now he thinks that the up here work is easier, but he's not a butcher anymore. We have 2 more of these. Okay.
Hey,
Problem 2.
look at this.
What's wrong?
F of x, they give us f of x and g of x. They tell us to find f composed with g of x and g composed with f of x. But then they ask something else. I don't think we mentioned whether composition is
Equal.
yeah. If we
Like-
went through,
Yeah, like if we went back, if they'd asked that question here, would you say yes or no? Are they equal? No, they're not the same thing. What about number?
generally,
They're not.
I think we could conclude generally, if they tell you to find f composed with the g and you give g composed with f, are you going to get the right answer? Mm-mm. Operations are classified as commutative and not commutative. Commutative operations are addition and multiplication. A plus B always equals B plus A. A times B is always equal to B times A. Subtraction and division are not commutative. A minus B, that doesn't usually equal B minus A. A divided by B doesn't equal B divided by A usually. And I think we can conclude that composition is not commutative. F composed with G doesn't usually equal G composed with F.
Look at number 7 to make sure. Definitely. One of them is 10 minus 24x. The other one is 35 minus 24x.
Certainly not equal.
But
Now, sometimes it may be equal, but those
Just not-
functions are a rarity, okay?
but
usually
sometimes
they're
A
not.
divided by B equals B
I
divided
know,
by A.
that
is
5
what
divided by 5, yeah.
Same thing with subtraction. 5 minus 5 equals 5 minus 5. So.
Yeah.
But okay, so number 10. F of x is 8x minus 2. And g of x is that a 1 over 8 parentheses x plus 2? Okay.
So they want us to find F composed with G and G composed with F. The only extra part here is at the end they want us to look and see were the final answers equal.
Okay. Oh gosh. So on this, sorry. Oh, I guess you didn't find that pizza. I know I have it on my
But it's a
phone.
very blurry.
Oh, it is. Oh, okay.
Look.
Does it under downloads or screenshot?
No, I just search.
Oh, okay. Here. F of x is the pizza. G of x is the pineapple. They're not writing the little O. They're writing it as F. This is F. This is fog x, and that's golf x. Fog x. You're putting G into F. Okay? So you're putting the pineapple on the pizza. With G circle A, or G composed with F, you're putting oops. You're putting the pizza on the pineapple. See, two different things, right? Here you're putting pineapple on the pizza. Here, the other one, you're putting the pizza on the pineapple. Okay? And it's too bad they didn't like Fog X and Golf X. Maybe they didn't have the little circle to draw.
Probably they didn't.
Okay, so number 10.
Oh,
Plug G into F. So I'm plugging this into F. So in place of that black X, this is going to get messy. In place of that black X, I'm going to put a 1/8 X plus 2. I guess it's not going to be that bad. But we still have the black minus 2. So in place of the black X, I'll put the 1/8 X plus 2.
remember, you multiply from left to right. And so don't let those fractions, what's going to happen here, it's going to work out very nicely.
What's going to happen with this 8 times 1/8?
And all you have is just a 1
One.
to distribute. The 8's cancel. You distribute a 1, that just gives you an X plus 2.
We have the blue X plus 2, and we still have this black minus 2 here. Let me go ahead and mark out those 8s to make sure it's clear. I'm saying, okay, those cancel out. We're left just a 1. Just get an X.
Circle.
Yep.
Now, we've been going so long, I better come over and type in
Type
that
in
answer.
X.
I don't want them to time this out.
So next we're going to find G of F, and now the only way, then they're going to ask the question, are they equal? The only way they'll be able to say yes, they're equal is if we get what answer for the next one?
X as well.
Mhm.
Well, let's see.
Let's see. F of X is 8X minus 2.
I think it's a good idea of recopying
Yes,
F and
I'm
G.
recopying it because of all
It's so messy with the little
the arrows. So we're finding G of F of X. So let's see. What are we plugging where? Exactly. Did y'all hear that? We're plugging F into G. So I'm going to take this 8X minus 2 and plug it right there in place of that blue X. Y'all see how I'm doing that? I'm replacing this blue X with the 8X minus 2. So I still have the blue 1/8.
And what else will be inside the parentheses?
In place of the X, I'm putting the black 8X minus 2. In place of this X, I'll put 8X minus 2. So I still had the blue plus 2 in the parentheses. That's what this is here.
I think you can simplify the inside the parentheses. Something nice is going to happen inside there. What is it? Okay.
The 2's I'll mark out. 2 minus 2, basically. Did y'all hear that? The 1/8 times 8 is going to cancel. What are we getting as this answer here?
We have
Just
1
X.
times X, which is just X. Any questions on how that, the substitution and how it cancels?
Excellent.
The only part I was confused about was I put 1 in parentheses 8x minus 2, and then I put another in parentheses x plus
Oh, wait, if you would did this, there's nothing wrong with that.
Is
Put
that
it-
what you
and
do?
another in parentheses with x plus. Oh, right, you're supposed to eliminate x.
That
Well-
X is being replaced
I got you.
with the black 8X minus 2.
And then it asks, are they equal?
So I've typed in X. then they ask, were those things equal?
And the answer is yes.
So write it. Are they
Mhm.
equal? Yes.
Mm-hmm.
So we select, oops, right there, and come back over here. And yes, they are equal.
Now I think number 11 has the same,
Instructions,
but
some messier
look
functions.
worse. F of x is the cube root. Ooh, we don't see many cube roots, do we? Of 3x plus 2, and g of x is, oh wow, 1/3 x to the third minus 2/3. Well, find f of g of x. Oh wow. Oh yeah. F of g, that means plug g into f. So plug g into f. So I'm going to write all that black stuff, but instead of the black x, what am I going to put? It's going to look messy. Cube root 3. I'm going to go ahead and put some big parentheses in place of the x. The black x, I'm going to put all of this stuff in there. So that's the blue 1/3 x to the third minus 2/3. Oh gosh, okay, distribute the 3 through those parentheses and you're right. What's going to happen? Not the square root. She's getting ahead of us. The 3 times a third is just going to be 1. So we'd have an x to the third. Then what right here? This 3 in the bottom cancels with that 3. So a minus 2. And then we still have the plus 2. So now the 2 subtract out. Okay, so 3 times a third is just 1. The 3 cancels. So 1x cubed. 3 times 2/3, the 3's cancel. So that
may have been better if you'd written the x cubed minus 2 in
blue. I know, I said I messed up with the color. Well, I thought it anyway. But now I'm going to start marking out.
What can we cancel out? What disappears?
Okay.
The negative 2 plus 2. So you just have a cube root of x cubed. That reminds me of something we did at the very beginning of the semester.
This and that cancel out. A cube root and a cube cancel. No? No. A cube root and the cube would cancel out just like a square root and a square. Just to x. I'll give y'all a hint. On problems 10 and 11, the answers are x, yes. So if you're going to do the assignment today and you remember that, great. Oh, I shouldn't have.
But it's trying to prepare you for the definition.
1 week from today, I'll begin the class, or we'll begin it.
Do y'all remember problem
this.
10 and 11 from homework number 18 or whatever number this is?
Assignment 18, whatever. Where we get x, yes.
Those functions are said to be inverse functions
Of each other.
So, and these problems here are trying to prepare you for that formal definition of inverse function.
1 week from today. Okay, I'm rewriting f and g. And we're about to do the last part of this. We're finding g.
Now we want g composed with f of x. I don't think I typed in the answer for this first.
Oh, okay, type it in.
Just an X.
Okay.
Now we're going the other direction, G composed with F.
So I'm plugging what into what? I'm plugging f of x into g. Okay.
Okay, you're calling it out. So you have 1/3.
Okay, so I have a blue 1/3.
Blue 1/3.
The cube square root of.
Okay.
In place of that blue x, I'm putting the cube root of 3x plus 2. But notice I still have that blue cube. The only thing that's getting replaced is that blue x. I'm going to go ahead and put parentheses like that.
You replaced the X.
Yeah.
Okay.
Mm-hmm.
Right.
You see how I did that?
The X with that cube root of 3x plus 2.
Now stuff is going to start canceling.
Cube root being cubed. What happens?
Those cancel. So I'm
Once
canceling
we
the cube and the cube
inverse
root.
functions next week, we'll say with inverse functions, when performed consecutively, they cancel each other out, leaving whatever you started with. And that's what's happening here. The cube is canceling out the cube root. And it doesn't matter the order.
Mhm.
Okay? It doesn't matter
Yep.
whether the order, as long as the cube and cube root are performed consecutively, they cancel each other out. So all we really have is, I'd rewrite the blue 1/3 and then the parentheses 3x plus 2.
Okay, so we've canceled the cube and the cube root. And now distribute that blue 1/3. And what are we going to have? The 1/3 times 3.
Just 1x, so x
Mm-hmm.
plus,
What's 2 times 1/3? 2/3.
remember that's 1/3, that's 1/3 times 2 over 1.
Mhm.
1/3 times 2, that's like 1/3 times 2 over 1. 1 times 2 is 2, 3 times 1 is 3. And what's going to cancel out here?
What are we left with? X. Two functions that cancel each other out like that are called inverse functions. We'll define that in a week's time. But to answer the question, are they equal? Yes. Okay. So 10 and 11, XX, yes.
And yes.
Oh, wow. No problems with the video? Number 12 is a cut point problem that you should have done a million times by now. Well, not that many.
Yeah, 12 and 13 we decided to end off with cut point problems.
Oh, but there's only 13 problems?
I think.
Yeah. Okay. Okay. Two long ones.
Okay.
Any questions?
And just because
over
we
the-
don't do the review problems at the end, remember you got to do them if you want to get credit for them. Okay, so any questions? Well, it's good to be okay. It's good to be
I
back,
feel like I'm going.
and
Okay.
About your whole video.
Yeah.